Hello and welcome to an introduction to relations and functions. Alrighty, so if relation is a set of ordered pairs with or without an equation. The domain of a relation is the set of all x coordinates, while the range is the set of all y coordinates. So if we're to find the domain and range, the domain is usually denoted with D. Then you have a finite set or a countable amount of uh, values. All you do is list from least to greatest the x coordinates. So you have -2, -1, 0, comma 1. Oh, excuse me. Not 1. 4 and 5. And for the range, denoted by R, open up curly brackets, and from least to greatest, the y values would be 0, comma 1, comma 5, comma 6. Okay, for number 2, the domain for all the x values from least to greatest, if you look, should be -2, 1, 4, and 5. While R will be the y values or the 6's, just 6, since they all share that. Okay, and the domain for 3, if you look, they all share the same x value, so it's -4 for the domain. While the range from least to greatest should be 0, comma 1, comma 5, comma 6. Righty? A function is a set of ordered pairs in which x coordinates have exactly one y coordinate. Each x is paired with one and only one y value. A function cannot have two ordered pairs with the same x and x coordinate but different y coordinate. So if we look, let's list the domain and range. So let's have 7, -4, 0, and -1. And if you see, they all share the same y value. So if we were to group these together, it would look like this. And you have to ask yourself, is that a function? And yes, it is a function. Alright, now to list for 2 the domain and range. To list the domains, let's have 2, -2, 9, and 1. And to list these, the ranges, we have 3, 7, 6, and 5. And if you were to match these, each one has a different corresponding range. So yes, this is also a function. Now to list the domain and range for this last example, -4 is the only thing in the domain. Well, we have 6, 0, 1, and 5 all sharing the same domain value. So this is not a function. Of the three, this is the one that is not a function.